Dear learner, let us start to learn about combined spectra problem analysis 7. So today we reach to the 7 number the spectra. After analysis 6 spectra, you enjoy the learning. So today we'll discuss with the help of NMR, mass, IR and UV. This four are the pillar of the spectroscopic analysis and to identify the structure. Let us start to do that. So spectral data is given. The first and foremost goal of us is to circle or to round or to highlight whatever the very important data for us or to underline it. So in case of IR, if we see these are the data, among them we will see this 3400, then 3050. These are two important data. Then 1600. This is also one of the important data. This is always there. This is always there because it is a aliphatic carbon and hydrogen stretching. Let us see this NMR. This is very important data for us, and to understand also we have 1.2 triplet 3H, we have a 3.1 quartet 2H, we have a 3.3 singlet 2H, then we have 6.5 to 7.5 multiplet 5H. Among them there is no required to do the highlight, but all the data are very important for us. So here we have a 3H, 2H, 1H and 5H. So if we calculate a total hydrogen, that is 3 plus 2 plus 1 plus a 5. So we can say total number of hydrogen are present here is 11. There is not given a molecular formula. There is not given a straight line molecular weight also, but from the mass M plus signal is given at 121. What it indicates? It indicates that the molecular weight of this compound is almost about 121. Let us, based on 13 rules, we calculate a possible molecular formula. So if we see here, then in case of molecular formula, we do apply the 13 rules. So 121 divided by a 13. So if we will do the 13 and 9s are, that is 117. So we are getting the value that is 4. So this is our N, this is our R. So according to this, CnH2n plus R. So our molecular formula could be expected, that is C9H. 9 plus 4, that is a 13. But if we check a NMR, that indicate that there are possibilities of 11 hydrogens. So there are 2 hydrogen or less. And a very straightforward, if we see here, the 2 hydrogen we have to decrease if the chances of nitrogen is there. Here again it is given 3400, that also indicate a presence of nitrogen or oxygen. Let us calculate a degree of unsaturations from that. So we come to the conclusion, if we are getting the fraction number of degree of unsaturation, then chances of nitrogen is more. So degree of unsaturation from nitrogen and hydrogen only is N minus R plus 2 divided by 2. If we do this, then what we are getting? We are getting a 9 minus 4 plus 2 divided by 2. If we do this, then we come to the conclusion that is about 7 by 2, that is 3.5. But degree of unsaturation is always most probably in the round figure. If it is in fraction, then chances of match it with this fractional degree of unsaturation, replacement by fractional degree of unsaturation. So always if you calculate with the help of N and R and there is a fractional degree of unsaturation, chances of nitrogen could be there. So here from this molecular formula, if we remove the CH2, or we again rewrite it here and do it. Our molecular formula, based on that, we are getting a C9H13. We remove the CH2, add nitrogen. So what we are getting, C8H11 and a nitrogen. This is the most possible molecular formula we can say, because hydrogen is matching with NMR, and NMR is very important tools to calculate it. So let us go ahead and understand NMR. So in case of NMR, we are getting a triplet and quartet. So triplet and quartet are there. It means the fraction fragment is there. This fragment is always present if 3H is a triplet and 2H is quartet. Second, this value is very important for us, NMR value, because this NMR value we are getting a aromatic compound. It shows the 5H. That also indicate that the chances of monosubstituted. So I could write here this fraction is possible. Now here we have a confusion with this 3.3 singlet. With 3.3 singlet, we come to the conclusion there are chances of OH and there are chances of NH, not NH2 also, because 1H is there. So if the OH is present, then there is no possibility of to, or we have to confirm it with this help of IR, as well as a fractional degree of unsaturation indicate that the chances of nitrogen is more. So one more fragment we are getting is this. Okay, let us go ahead with this IR. From the IR we come to the conclusion NH is present from 3400 centimeter inverse. Then 3050 is indicate aromatic H stretching. This is possibility. 1600 centimeter inverse indicate C double bond C stretching. These are the possibilities of that. So if we join together all the fragment, then we could come to the conclusion, and the possible structure we make it here is this is only, no anyone, because there is mono substituted. This is NH, this is CH2, and this is CH3. Now this is a possible structure from this given data. Let us conclude and confirm the test. So if we have this NH, CH2 and CH3. So here we have confirmed the data of this one is mostly from NMR. Then for IR, this is mono-substituted from the NMR due to 5H. This fraction is very important. It give here that is 3H, 2H, 3H triplet and 2H that is a quartet. If mass is there but it is not given, if it is here, then also we can come to the conclusion for here. This is not going to be fragmented because it is written here it is singlet. I have told you so many times that when this proton is acidic proton, it is present on electronegative element, it is continually exchangeable, so it will give the singlet. So it is not a matter whether we are getting for that. So most probably people can conclude from the triplet or quartet. More than that, multiplet, we cannot come to the conclusion. So these are the possible structure of a confirmed test of that. So this is our 7th spectra. If you want to continuously learning, then enjoy spectra analysis, and this is very important part of analysis.